Moon impact fallout. Odds of a huge asteroid hit are rising. Coming up, what happens if giant asteroid 2024 YR4 slams into the moon? And what does 30% really mean? Imagine the familiar pale face of the moon. Now picture a bright dot hurtling through the blackness of space. That dot is big and moving incredibly fast. This is not science fiction. This is the scene flooding news sites and social feeds right now. New data from the world's most powerful telescopes suggests a large asteroid may cross the moon's path, and the odds keep increasing. Scientists, usually calm, are watching with intense focus. In those first seconds, you likely feel a chill run down your spine. Could our constant companion, the moon, actually be hit? The number that captured everyone's attention: 30%. Some early estimates, based on initial, incomplete data, suggested the chance could rise that high or more in the coming months. That single figure, a 1 in 3 possibility, sent shockwaves worldwide. It turned a distant event into something deeply personal. The moon is not just a rock. It's part of our culture. It's part of our history. It's part of our night sky. The thought of it being struck is unsettling. Coming up, we will explore what this risk means. We will look at the potential consequences and what might follow in the days and weeks ahead. The story is just beginning. This is a journey into modern astronomy and planetary defense. Be sure to watch until the end so you don't miss anything from our journey. I would love to hear from you in the comments below. The discovery of Asteroid 2024 YR4 was not an accident. It was the result of a tireless, global effort to watch the skies. Astronomers use a vast network of sophisticated tools to perform this cosmic patrol. Powerful telescopes perched on remote mountaintops here on Earth systematically scan the darkness night after night. They are programmed to look for faint points of light that move against the fixed background of distant stars. These moving dots are the telltale signs of near-Earth objects, or NEOs. In addition to ground-based observatories, we have allies in space. Hubble, James Webb, dedicated survey missions provide an even clearer view, unhindered by Earth's atmosphere. When this particular object first appeared as a faint streak on a digital sensor, automated software flagged it as something new and noteworthy. This initial detection triggered an alert, mobilizing a community of astronomers. Observatories around the world were tasked with turning their gaze toward this specific patch of sky to gather more data. Each new observation, each new picture taken, helps to refine our understanding of the asteroid's orbit. The first few data points create a very rough sketch. As more information flows in from different locations and at different times, the sketch becomes a more detailed and accurate drawing of the asteroid's future path through the solar system. Once enough initial data was collected, teams at institutions like NASA's Jet Propulsion Laboratory and the European Space Agency began their crucial work. They fed the observational data into powerful supercomputers. When scientists talk about odds, like a 30% chance, it is important to understand what that number truly represents. It is a measure of uncertainty. In the vastness of space, predicting the precise path of a small object millions of kilometers away is incredibly challenging. The 30% figure is a snapshot in time, based on the limited information we had at the moment of discovery. It means that, given the current data and its margin of error, there is a significant, non-zero probability of an impact. For space risks, a probability this high is considered very unusual and warrants immediate and serious attention from the global scientific community. However, this number is not set in stone. In fact, it is almost guaranteed to change. As astronomers continue to track the asteroid, every new observation helps to shrink the cone of uncertainty around its predicted path. Think of it like trying to predict where a distant car will be in 1 hour. If you only see it for a split second, your prediction will be very broad. But if you watch it for several minutes, you can make a much more accurate forecast. The same principle applies here. More data leads to less uncertainty, and the probability of impact will either climb toward 100% or, more commonly, fall dramatically towards zero. Scientists use various techniques to get this better data. High-resolution optical telescopes capture sharper images. An even more powerful tool is planetary radar. Bouncing radio signals off the asteroid's surface, a cosmic collision course, size, speed, and impact. Understanding the potential consequences of an impact begins with two fundamental questions. How big is the asteroid? How fast is it moving? The answers determine how much energy would be released on collision. Early reports call it large, but that covers a huge range in astronomy, several tens of meters across, like Chelyabinsk in 2013. Hundreds of meters across, a much greater concern. Scientists are still calculating exact dimensions by analyzing brightness and by hoping for direct radar measurements. Speed is the other critical component. Asteroids travel at tremendous velocities, often many times faster than a rifle bullet. Example, an object approaching the Earth-Moon system might be 20 kilometers per second, roughly 72,000 kilometers per hour. Impact energy grows with the square of velocity. Double the speed, quadruple the energy. So a moderately sized but very fast asteroid can release energy like many nuclear bombs. Size plus speed sets the scale. A smaller, slower rock, a bright flash, and a crater a few dozen meters wide. Scientifically significant, not catastrophic for the Moon. A larger, high-speed rock. A crater many kilometers wide and kilometers deep. Right now, measuring size and speed is a top priority for observation teams. And right now, it is looking large. Roughly several hundred feet across, around 20 kilometers per second. Lunar scars. What a direct hit would do to the Moon. If this large asteroid were to strike the Moon, the event would be spectacular and violent. The Moon has no significant atmosphere to slow down or burn up an incoming object. It also has no oceans to absorb the energy. The full, raw force of the impact would be delivered directly to its rocky surface. The moment of collision would produce an incredibly brilliant flash of light. The asteroid's kinetic energy converted into heat and into light. This flash could be so bright that if on the side facing Earth, it might be visible from our planet, even to the naked eye, as a momentary spark. Immediately following the flash, the impact would excavate a massive new crater. Rock would be blasted upwards at high speeds. Lunar soil, known as regolith, would be blasted outwards at high speeds. The scale of this explosion of debris would be immense. On Earth, our thick atmosphere would contain much of the damage, and strong gravity would limit its spread. But on the Moon, with its airless environment and weak gravity, the debris plume would rise high into the vacuum of space before raining back down over a vast area. This ejected material, or ejecta, would create bright new streaks, called rays, radiating from the impact site, similar to those around Tycho and around Copernicus. The surface of the moon near the impact would be fundamentally transformed. The new crater would be a permanent feature, a fresh scar on the ancient lunar face, easily visible through telescopes from Earth. The heat and pressure of the impact would melt rock, creating glassy particles and beads scattered across the lunar landscape. Earth's view. Could we feel the tremors? With the moon being our closest celestial neighbor, the question of how an impact there could affect Earth is both natural and urgent. The good news is that for the vast majority of potential lunar impacts, even large ones, the direct physical risk to people on Earth is extremely low. The moon's own gravity is strong enough to capture most of the debris thrown up by the collision. Most debris falls back to the moon, while a few small pieces escape into space. The bulk of the ejected rock and dust would follow a ballistic trajectory, arcing high above the lunar surface, before falling back down to create the ejecta blanket and secondary craters. Earth is a relatively small target in the vastness of space. However, a truly massive impact could theoretically send some fragments into space with enough velocity to escape the moon's gravitational pull. A small fraction of this debris could, over time, find its way into an Earth-crossing orbit. If this were to happen, we might see an increase in the number of meteors or shooting stars in our sky in the weeks and months following the event. Most of these pieces would be no larger than grains of sand or small pebbles, and they would burn up harmlessly high in our atmosphere. The more probable effects would be minor, manageable risks for satellites mitigated by orientation maneuvers and monitoring. Earth would serve as the grandstand for a spectacular but distant cosmic event, unless it breaks apart. The path forward. Science, vigilance, our next step. We began this journey with a moment of shock, a viral news clip, a startling number. We have since stepped back to understand the story behind that moment. We have seen how dedicated astronomers hunt for these objects, how scientists use powerful models to calculate the odds, what a potential impact on the moon in December 2032 might truly entail. This entire event serves as a powerful demonstration of why consistent, patient sky watching is so critically important. The initial alarming probability does not signal impending doom. It signals that our planetary defense systems are working, giving us the warning we need. Ready to dive deeper into the matrix? Watch the next video to see just how deep the rabbit hole truly goes. And since you made it this far in our journey, be sure to share your experience in the comments below. We must seek out information from trusted, credible sources and resist the urge to give in to sensationalism or panic.